my name is Brent Elliott and I'm an applications engineer for MEGADYNE. Please subscribe for more information on belt installation and maintenance. You'll notice in all of our videos that we're not wearing any personal protective equipment. However, this is a demonstration stand with no power and no potential for personal injury. Anytime you're in the field installing a belt or doing maintenance, we highly recommend following all safety procedures and wearing any personal protective equipment that's necessary. At MEGADYNE and all mega companies, we value your safety over everything. We're going to talk about 3 different methods to measure a misalignment or alignment. The first is going to be the laser alignment tool. It happens to be the most expensive of the 3 different methods, but it's actually the most efficient. We'll talk about that near the end. But the way this works is it has a laser. So when you turn the unit on, you see this laser line. It's going to shine in a very straight method. It's actually magnetic, so whenever you take this, you're going to magnetize that to the outer face of this pulley. It has targets that basically nest inside the unit right here, but you're going to take those out, and they're also magnetic, and they're going to magnetize on the face of the pulley. And we're going to start off with one target at 12 o'clock and one target at 6 o'clock on the pulley face. So these targets are actually adjustable. So if you slide this inner portion in and out, you'll notice that it actually clicks in the center. So typically you're going to slide it until you feel that click in the center. You need to do that on both targets. The reason it is adjustable like this is because if you're using pulleys of different brands, or one of your pulleys is a flywheel, a lot of times the distance from the edge of this groove to the face of that pulley is a little bit different, and you need to adjust for that when you're measuring this alignment. So we're shining a laser and it hits the targets. The reason we have it at 12 and 6 is because you need to measure all 3 different types of misalignment. So in this setup, if we notice that the laser is off from both targets, either back or forward, we know that we have offset misalignment, and that's the easiest to correct actually. So what we do is we take the bushing, we loosen that up, and we just move the pulley in on the shaft or out on the shaft depending on where the laser's at, and the laser will help us know how far to move that. So then you lock that down and you're good. However, if the laser is hitting the top target but not hitting the center of the target, bottom target, that means we have horizontal vertical. So in order to correct that, we're going to need to shim the motor or shim the driven unit, either on the back or front, depending on which direction we need to correct the misalignment. And we're not done there. So at that point, and when you get those 2 alignments corrected, you're going to want to move the targets to 3 o'clock and 9 o'clock on the face. And at that point, you do the same thing. You look where the laser line is hitting the 3 o'clock and the 9 o'clock target, and that will tell you whether the shafts are towed in or towed out from each other. And if they are, obviously you need to correct those. And that's how you measure all 3 different types: offset, horizontal angular, and toe in, toe out using this device. And it's actually more efficient than the other methods we're going to talk about, because under normal circumstances, what you're going to do is you're going to align the pulleys, and then you're going to tension the belts. And when you tension the belts, it can pull the pulleys out of alignment. And then once you get it aligned, you need to check tension again. And a lot of times you have to go back and forth to get both of them correct. With the laser alignment tool, what you can do is, as you're moving the motor or moving the pulley farther apart, you can keep an eye on the alignment at the same time that you're measuring the tension of those pulleys. So basically it makes you more efficient, and you don't have to use as much time whenever you're installing your belts.